Good morning to everyone. I'd like to thank Paint Istanbul for the opportunity to speak with you today about how global megatrends drive innovation. We're going to talk about the idea that their megatrend can provide a futuristic look into the way that you can develop new products and see pretty much a guide into the future. So what is a megatrend? Megatrends represent really changes in our world that have a sustained impact on everyone. For example, the COVID crisis had a sustained impact on everyone. And it is a driving force, megatrend, towards the likely future world. And this is characterized by global patterns that are related to our behavior, our mobility, and the environment. There are often structural shifts that accompany a megatrend that have long-term and significant consequences. And it drives our decisions around things that happen in our society, things that happen in business, industry and economics are affected, and the environment is affected. So it can point to the future for growth opportunities if you're paying attention. And in short, so a megatrend has direction, it has momentum, and it has a causal effect. So let's take a look at all the megatrends that we have today, and we'll begin talking about them. So these are all the megatrends in today's world, and we have quite a few here. And we're going to start by talking about digitalization, and then we're going to go to global health and around the circle here. So digitalization really covers a number of topics, including our data security, our artificial intelligence, the big data that we deal with every day, augmented reality, 3D printing, and robotics. These are all covered under digitalization. If we didn't have the Internet of Things and how we digitize information today, we couldn't have any of these other features that we're going to talk about or these other topics. So let's look at industrial augmented reality. So this is new to the industrial scene, although it's being used in many different areas. It's used to improve our productivity in the workforce, to drive customer satisfaction by giving you more higher quality and less waste and less rework into your office. And so you've got basically augmented reality is using computer simulations to give you these on-screen looks, for example, in these photographs, the on-screen to show you how to do things. And the idea here is to provide training and logistics for order picking, for maybe assembling parts and having better quality control. So the workers here are seen picking orders in a warehouse and so forth. So there's augmented reality technologies out today that allow you to improve your quality and your productivity. The oil and gas industry, for example, is utilizing this technology to train their workers on oil infrastructures, on the offshore oil rigs, to improve their operations and train their workers. So this is an opportunity to use a technology to help better the workings inside your organization. 3D printing is known as the third industrial revolution, and it's a computer-controlled production technique that allows you to build a product layer by layer. And this is a huge market. It's valued right now at $12.6 billion, and it's estimated to grow to $35 billion by 2025, and it's growing at a rate of 22.5%, which is very large. The driver for 3D printing is the fact that it is enabling you a way to do very customized and very complicated parts very easily. So you can actually make parts that are very complicated in a very easy way. And people use it for prototyping, they use it for functional parts, and they use it for tooling. And they're made, the materials are made out of a lot of different things. They're made out of plastics like ABS and nylon and PLA. Photopolymers are used for, and they are UV cured or heat cured. And they even print with metals and aluminum and titanium and nickel. So there's things in these 3D printing operations that allow you to do many different things. But what about paint? What is the connection to paint and 3D printing? Well, the parts come out of the 3D printer and they're kind of rough, and sometimes they need to be smoothed out in order to work properly. And instead of taking the time and the money to sand these parts, it's easier just to paint them. And so the application of coatings via spraying, brushing, or dipping is a way to smooth these parts out in a very efficient way. And this is an epoxy coating on a 3D printed part. So 3D printing is huge, but indeed it can not only be used to make parts, but in this example, it's used to print houses. And in Austin, Texas, in the United States, we have a 100 home community that is going to be 3D printed. And these houses are made out of concrete, and it kind of squeezes out the concrete. It can make a curved wall, for example. And it only takes 3 people to make a house in 1 week. So there's very little labor involved in constructing the house. And the idea here is to create houses faster when you have housing shortages, as we do in some communities here. And the idea is to also create a cheaper version of a house. Unfortunately, right now, the pricings are high because we're still starting with 3D printed structures. I think the common price now is pretty even with a normal house. But as more and more 3D printed structures are made, the pricing will come down, and this is going to become more and more common. Now you'll notice that these houses are made of concrete, and so when you paint this house, instead of using a house paint that might be used for wood or other types of siding that is applied to a house, you're going to be looking more at masonry paints for concrete. So this is a very interesting trend, and I think we should be keeping an eye on it because I believe this is going to be seen more and more in the future. In addition, robotics and learning tools, on-demand computing is used in the laboratory now, and this is another part of the digitization megatrend. So you can use tools within the laboratory that allow you to work faster. And on the right here, we see a robot. It's from ChemSpeed Technologies out of Switzerland. And this robot allows you to make maybe 100 formulas a day, paint formulas a day, and test them. So it gives you some data as well as making the formulations. And you can then find the sweet spot in a formulation tool set where you're looking for various types of characteristics. And as you formulate, you can find exactly what you're looking for utilizing a technology like this in a much faster way. Now, this technology is not cheap, but many of the large paint companies are implementing these technologies in their companies today and in their R&D workforce. So there's many tools you can find out there that allow you to do virtual computing, and improve your formulation capabilities. We don't advocate at ChemQuest any of these in terms of endorsements, but we are giving these as examples to show you what is possible. In addition, robots are being used for applying paint. And this is a company in Jacksonville, Florida. They're called Apelix. And they partnered with AkzoNobel in the Paint the Future contest. And what they did was they have developed a robot that actually paints, and it also allows you to take measurements of paint film thickness at elevated sites like tanks and things that are very high in the air, the tallest part of a building or a bridge. And it allows you to apply paints or take measurements. And also they're now starting to work with cleaning technologies. So you'd be cleaning the surface, and you could paint the surface and then measure your dry film thickness with the same tool. So this technology is coming along very nicely. They're starting to really roll this out, and you'll be seeing more robots in the future painting substrates. So you should be aware that the paints that are used in these, they need some modification in order to be sprayed through these devices. But this is a very interesting technology, and I've seen this robot myself, and it's really impressive. So a very cool technology. In addition to digitalization of all these other tools we've seen, there's also the packaging that we use in our products. Now, packaging is normally a box. You put a paint in a can, and then you put that in a box. But there are sophisticated tools that we can use to track and trace these boxes if we need to. For example, if it's a very important product that you want to find in the supply chain, you can use near-field communication devices or radio frequency identification tags, known as RFID, which allow you, if you combine this with blockchain, to actually trace your product through the supply chain. And for many companies that do pharmaceuticals or other things like that that are critical, mission critical products, this is very important. But smart packaging is used in all sorts of areas, and it also allows you to communicate with your customer. For example, a QR code is an idea of a smart packaging, and that can be used if you point your phone at the QR code. It can then talk to your customer and tell them, oh, this is what the product does, this is how the product is to be used, and this is what it looks like when the project is done. So this is a very effective tool to help communicate with your customer. So smart packaging is part of digitalization. If we didn't have digitalization as a megatrend, we'd never have smart packaging. So that concludes the digitalization section, and we're going to move on now to global health. So global health is very important, as we've seen now with the COVID pandemic. It's affected everyone, and it's brought us to new areas of research, for particularly antiviral research and prevention and antimicrobial paints, and our regulatory environment has changed slightly. And so we have an aging population, and the COVID pandemic has affected them, but it's really affected everyone. And as a result, in the United States, the National Science Foundation responded very quickly by accelerating the approvals of proposals for antivirus technology. So you could submit a proposal for an antivirus technology, and it would get reviewed very quickly and hopefully funded by the National Science Foundation to do the research in order to develop this technology and get it commercialized. So the paint and coatings community responded with record number of applications for funding opportunities to this call from the National Science Foundation. And from that, we hope there'll be a lot more solutions to the problem, as not only this virus, but future viruses affect our communities. And so this is really an important aspect of what paints and coatings can do for us. And in fact, what are the drivers for this? So if you go to the hospital, you can acquire an infection just by being in the hospital. It's called a hospital-acquired infection. And it creates thousands of deaths in the US alone. And it's very a big deal, basically, because you want to try to shut down these viruses and these ways of virus getting in contact with people by touching contaminated surfaces. So this is a problem in hospitals, but it's a problem everywhere, really, because you've got doctors' offices, you've got food production facilities, you've got daycare centers and schools with kids, nursing homes with older adults. You have public spaces like gyms and airports and cruise ships. So, you know, there's always a way to a vector for these viruses to get around. And it's in fact really the high contact areas that these viruses tend to settle, such as the handrails going up stairwells, door handles going in and out of doors, the countertop, the medical equipment, the textiles and the furniture. These all are surfaces that are vectors to transmit viruses or microbes in general for the spread of infection. So we need to create solutions for this problem, and so we can put additives and coatings to prevent the growth of microbes. So what are some examples? These examples include quaternary ammonium compounds. Now, these are cationic surfactants, and they're positively charged materials, and they are really highly effective at killing the infectious agents like SARS and or COVID, and they impact the cell wall and the membrane after contact. And so they're very effective, and they're used a lot in cleaners, for example. Lysol is an example that uses a quaternary ammonium compound for killing viruses. But there are other additives as well. Silver nanoparticles is one particle that is used for killing bacteria. Copper is also available, as well as graphene. So these three areas, graphene is actually newer. The material is being studied for its antimicrobial properties. So it is the newest member of the team here in terms of additives that can be put into paints. But here's some examples of products that are already on the market. There, in the United States, when you claim to kill a pest like a virus, you have to have it registered with the Environmental Protection Agency. So that's the EPA. And the EPA is responsible for making sure that it's safe and can be used in public spaces. So Sherwin-Williams developed a paint called Paint Shield. It uses the quaternary ammonium compound. It's a patented material. I worked at Sherwin-Williams for 35 years, so basically I was actually involved in this project a little bit. And so it's a very effective product for meeting the needs of antibacterial paint. On the other side here, we have a new product that just came out from PPG. It's called Copper Armor, and it uses a copper technology. They licensed this technology from Corning. They have a copper-infused glass material that allows the copper to come out slowly over time. And they have shown that it is effective against Staphylococcus and MRSA and E. coli and SARS. So these are very important tools that can be used to control bacteria in public spaces. So that concludes that section. We're going to move now to reshoring for economic stability. And what does that mean exactly? Well, you know, we've had a lot of trouble getting materials. Our supply chain has suffered from some instabilities. We've had a lot of shifts in our commodities and so forth. So I think that it's important to understand that this is a big trend right now in terms of how people are responding to getting our raw materials. So the big message in 2020 and 2021 is out of stock. Many people have been out of stock of products because they could not get them. They could not get them. And what contributed to this situation? What in the United States, I'm going to be very specific about what happened here, but it affects all of us because many of our products get shipped all over the world. And so what happened? Well, first of all, let me talk about our recovery. We came from COVID and recovered rather rapidly in terms of economics. We didn't really suffer a big downturn in our economics. But what happened when people were out with COVID and being on quarantine, things weren't getting made. So our inventories were down. And so there was just nothing being made. And this created, a void. There was no product to be had. So Then when we had the recovery, we started to get our demand back, and we started to see things being made again, but there were shipping delays. There were people not on the job, such as truck drivers and people who are working in the transportation industry. And then the fourth kicker here was a winter storm in Texas. Now, that doesn't seem like it should be a big deal, but it is, and I'll show you why here in a second. So let's look at the delays and constraints in our shipping industry. And this is on the West Coast, for example. And you can see that all these container ships are sitting out here in the ocean, and they're just not getting into port. And only about 40% of the container ships were on time arriving at their ports. And there were all of these delays waiting for these ships to come into port and get unloaded. And in fact, there's an insufficient number of trucks and drivers to handle all these goods that are coming in. So we've got a backlog, or a log jam, some people call it, of materials that are just sitting out waiting to get unloaded. So this includes everything that we bring into our countries, whether it's our raw materials or our packaging goods. This is all just sitting in the ocean waiting to get unloaded. And this is seen from the truck and rail shipments. They've been hampered by the supply and demand and driver availability. That's been the main thing, is having enough drivers. And and the cost of trucking has gone really high. The trucking costs before all of this happened were about $3.50 US a mile. And now they're about $7 to $15 a mile. So that's 3 times higher, basically. And so we have constraints in getting our drivers. Our costs are higher. And we're basically seeing that this is hampering our entire operation of getting materials to where they need to go. And 20% in the United States of everything that we produce is handled by rail car. And so trains are up, the traffic rose 17%. And so it's just been very difficult to move product when you don't have it, basically. Why don't we have it? Well, here's an example. The storm happened last February. We had a catastrophic freezing event in the Gulf Coast of the United States. And in Texas, there are a lot of chemical operations, Louisiana as well. So the Gulf Coast of the United States was severely affected. As you can see here, the power went down and all of these plants froze. They just absolutely froze up. So you obviously can't do anything when you don't have the equipment working. This affected many of the petrochemical centers that we have in our area. As a result, they were shut down, and our crackers that were able to crack the petroleum were shut down. And once you have a cracker go offline, it takes a long time for it to come back up. So it was estimated that about 61% of our ethylene capacity was shut down, and 59% of our propylene capacity was shut down. And these are all chemicals that are used to make other things. So this allowed for this basic lack of supply of materials in this space. So this was a kind of a big deal and a very catastrophic event, and it contributed to these supply chain issues, which we still suffer from today. So that's why reshoring for economic stability is important, because we're trying to fix all of these problems and keep our raw material sources a little closer at hand. Many people were working on just-in-time and lean manufacturing processes in their facilities, trying to keep their raw material inventories low. And this didn't serve us very well in this case, because since we were already at a low area for keeping raw materials, then we didn't have enough when there weren't any there to begin with. So basically, we just ran out of materials. So the Americans, North American manufacturers have started trying to bring their operations back to the United States and keep them here closer so they can control them better. And so this effort's been going on. It's estimated to drive about $443 billion of value in the next 12 months back here in the reshoring effort. And the coatings manufacturers that we have worked with within ChemQuest have sought us to help them with their supply chain problems, finding raw materials, but they're trying to really stabilize their supply chain so that they can get the raw materials they need and can control it a little better from an economic point of view. So a very important area. We're going to move now to global electric vehicles, which I think is probably one of the most significant changes, megatrends that we have here. We're going to talk about battery technology, heat management, lightweighting, and sensor technology. So all of these things are really important with the global EV market. And why is it important? Well, because every major automobile manufacturer has announced plans for conversion to electric vehicles in 10 to 15 years. I was even reading about an electric vehicle company in Turkey that you guys have. So there are reasons that we will be very much concerning ourselves with electric vehicles rather than mechanical vehicles and motorized vehicles with mechanical motors or the internal combustion engine. So basically battery technology is where it's at here. And battery technology has a lot of problems that have to be worked around. First of all, they have heat management issues, lightweighting, charging stations have to be installed for your infrastructure. And we're going to see the transportation and delivery of goods of everything that we do being changed by using the electric vehicles. But indeed, not only cars or automobiles and trucks, but we're going to see drones being used for last mile deliveries, as well as electric air taxis, which are starting, these companies are starting to produce small airplanes for taxi services, and particularly in congested areas where you need to get somewhere fast from one area to another. And there's also short distance electrically powered airplane flights, which is really cool. And those are starting to surface. And in fact, there are people who are now claiming they have the longest flight with an electric powered airplane. Just in the days of when we had Amelia Earhart flying around the world claiming she was doing long distances, now people are saying they can do it with an electric airplane, which is very interesting turn in history. So all of these things create changes that are opportunities for coatings, but it's depending upon the type of coating that is going to be used for these electric vehicles that's different from what we do today. So these are some expanding opportunities in electric vehicles. So there was a gentleman in the car industry who said that the number of cars being sold is not likely to grow. So it's not the content. You're going to expand. You're going to grow by the content per vehicle, not just by the vehicle itself, but because the vehicle itself, the numbers are going to be the same. But you're going to have more types of coatings on the vehicle. So what kind of coatings could these be? Well, this is a schematic here of an electric car. And what's missing? A motor, the kind of motor that you normally see in the front of the car. So you have an electric battery system with an electric drivetrain, and basically very simplified look here of an electric vehicle. And these all have components that are electronic control units. There's more than 100 of them inside of these cars. They use batteries, they use power conversion components, they have electric drive systems, and they have battery packs, lots of battery packs in there to power the car. So what could we do here for coatings? Well, it's going to change from what we normally have today. We're going to have to think ahead here and say, well, what kind of coatings will I need for an electric car? Well, you're going to have cars that need to be regulated for temperature because these batteries can catch on fire. So you've got fire damage, you've got electrical interference, and batteries have to operate at an optimum temperature. So each battery manufacturer is going to be different, and they're going to have different needs. So if you're working to understand what batteries need, you're going to have to partner with a battery manufacturer and understand what they're doing and see how you can help them. So they all need, but the batteries all need fire protection. They need corrosion protection. They have to have impact protection because obviously these cars could get in an accident. There's temperature management and electrical shielding. So the thermal management is key to maintaining these batteries at their optimum. And lithium ion batteries are full of flammable solvents. So intumescent coatings are going to be needed to protect against fire damage. And then another thing that's very important is to prevent arcing inside the battery or dielectric coatings. And that's something that most folks aren't as familiar with. But if you're in the electronics industry, you definitely understand dielectrics. So again, to help out the battery market, you really need all of these new technologies and new coatings to impact the performance of the battery. And now we're going to transition to the next megatrend, which is less hydrocarbons and more carbohydrates. And what this means is that we're going to lessen our dependence on fossil fuels, create more bio-based materials, reduce our carbon footprint, have more sustainable systems, and reduce pollution. So every day in the trade journals, I see articles on carbohydrate-based raw materials being offered by people and being developed by companies. Consumers are very concerned about the planet. I'm concerned about the planet, actually, and we want safer home products in our homes that don't carry any hazardous warnings. And so this is not only about paint, but this is about everything that's in the home, including cosmetics and packaging that can be recycled, food, any of your home care, personal products, cleaners, for example. We all want them to be formulated so that they contain less harmful ingredients. And paints and coatings are no exception, and they can be reformulated to contain bio-based offsets. And many new materials are emerging every day from the literature as you follow this, if you follow this subject. And you can find that many companies like DSM, for example, Arkema, for example, are bringing new materials like this forward every day. The circular bioeconomy is pictured here on the left. And basically what you're talking about is the intersection of agriculture and forestry and climate and water and the energy industry all coming together to create what is known as the circular bioeconomy. And this economy is really about trying to reduce our dependency on the fossil fuels to lower our greenhouse gas emissions and to create a sustainable supply chain. And on the right here, you'll see the supply chain that's been created is around being able to recycle materials, taking raw materials from the field, creating a new raw material, creating a product. And then once that product is used and disposed of, it could be put into a landfill or it can be recycled and upcycled back into the system. So that would be a sustainable manufacturing process that allows you to keep harmful materials out of the landfill and the supply chain. Where do these bio-based chemicals come from? Well, there's mostly several feedstocks that are key to producing a whole new line of products that are offsets for the current fossil fuel-based products that we have today. So lignocellulose, which is pictured up here, is mostly wood, and lignin and cellulose both drive a large portion of new products, as well as green biomass like grasses, for example. And then we have starches that come from wheat and corn and potatoes, all large contributors to bringing new starches into the market and taking those starches and creating new products with them. Sugar is derived from corn and beets. We have carbon dioxide, which we can take from the air and then use for chemical conversion. Organic wastes are used to produce new chemicals after they've been digested. Those wastes can come from, let's say, food waste, for example. And then, of course, oils are being produced by algae now. There are algae farmers who are just getting the oil from the algae, as well as seeds like linseeds, oils, and so forth, that are palm oil, that are producing oils that can be then fractionated and used in various chemistries to produce glycerols and so forth. So they can be for biofuels or they can be used for other things. So they produce a lot of different types of chemical offsets to the current fossil fuel-based chemicals that we use today. So in the paints and coatings world, we can produce several types of resins from these bio-based materials. We can make alkyd resins, we can make epoxy resins, and we can make acrylic resins out of bioalcohols or diols or glycols. And so all of those are useful in making new resins. Now the resin costs are going to be higher because of the supply chain is not quite as robust as is the fossil fuel supply chain. But as the cost of fossil fuel goes up and the price of these bio-based raw materials go down, then you're going to find that these are going to be more attractive as bio-based materials. There are areas in the coatings market that have already been shown to be likely to switch to a bio-based or plant-based resin. So that would be wall paints and floor coatings, furniture coatings and lacquers, primers, wood decking and fencing, printing inks a lot of them are bio-based today. Textiles and textile inks and adhesives and artist paint. So these things have opportunities for switching into bio-based raw materials. So I think that we can look forward to more and more of these coming into the supply chain. And as we've seen, some people have already gotten there. These are examples of bio-based coatings. There's the product from PPG called or Sigma Coatings that actually is bio-based. They've gotten a lot of the raw materials from DSM in this product, and they call it an air purifying technology as well. So you can see that this has a lot of dual functionality, so it's a smart coating. Also, in the United States, Benjamin Moore has Natura, which is a plant-based paint. There's BioShield. There's Better Living with bio-based paints from Dulux. Durasoy, Vermont. There's a small company in Vermont called Vermont Natural Coatings, which makes a floor finish, which is, in this country, we get them certified as USDA, United States Department of Agriculture, certified bio-based product. And this is from Europe. Aro is a cradle-to-cradle product, which means that part of their raw materials can be upcycled back into the supply chain. So there's a lot of people already working in this area, but more and more of this is going to come forward as we get more and more raw materials from basically those new feedstocks. So now we're going to transition to the last megatrend I want to talk about today, and that's climate change. There's nothing more important today in my mind than the subject of climate change and what it's doing to all of us. Obviously a huge megatrend, but it's creating a lot of water scarcity, flooding, some resources that are scarce, and fire damage. So let's look at it from the fact that there's a lot of products, services, and technologies that are needed now to address the harmful effects that we see from climate change, like these increased environmental temperatures that we've seen across the world, water shortages and droughts, and then conversely, devastating storms that create floods. And then in the drier areas, we see a lot of wildfires. We've seen wildfires over the world, California in the United States, Australia, has seen a lot of wildfires. So this is not something related to just one area. It affects all of us. That's why it's a megatrend. But the World Economic Forum has seen that the planet temperature is going to rise a little above what they predicted. It's going to go to 2 degrees Celsius, which is a big change for us. So we are going to see more and more effects of this climate temperature increase for years and years to come until we can hopefully slow it down. The innovations that can be used in paints and coatings can be developed to address some of these problems. Obviously, we can't address climate change on the whole, but we can at least affect some of the effects from it by using paints and coatings. Financially, the climate change has a huge impact on, let's say, the insurance agencies. Okay, we all have insurance for our homes. Many people do, to insure our homes and our property. And as we've seen over time, these storms are getting more frequent and more expensive. So it's like, if you don't believe in climate change, just look at this data, because we still have a few climate change deniers out there, and but it's hard to refute the dollars being spent against the damage being done. And so here's Hurricane Andrew, which was back in the early 90s, and it created a 42% increase in the spending against the damage that was done. But as you go up in time, you can see we've had more and more of these massive catastrophic hurricanes that have created more and more damage. And this frequency is getting more frequent, and it's getting more powerful and causing more damage. So these things are real, and they have to be addressed. So how can we address in the coatings industry this problem? Well, we're going to need better durability, because if it's getting hotter outside, the coatings are going to have to be much more durable. So people are going to have to develop coatings with a lot higher expectation in terms of how long they last outside. Because of the storms and because of the increased amount of rains in some areas, water repellency is important, and also mold and mildew resistance, because as you can see in this picture here, when you get flooding, you get a lot of mold and mildew growing along this line here. And basically, when it's wet and hot, that's a perfect environment for mold and mildew to grow. Better UV resistance, obviously, if there's more sun and less clouds and less rain, there's going to be a lot of UV, and the UV is getting stronger. That has also been measured. And so it's going to be important to have good UV protection in your coatings. And that's going to be on anything that's outside, is going to have great UV resistance. The application temperature ranges for paint are going to change, because if it's hotter outside, then you're going to be applying paint when it's hot. And it's going to be difficult to apply paint at certain temperature ranges unless you can sort of make adjustments to the paint itself, to the formulations, in order to make them more easy to apply at higher temperatures. And I know this is difficult to do, but you're going to have to find ways to figure this out. Then there's also fire-resistant paints. If your roof is catching on fire and burning, if these shingles, for example, were coated with fire-resistant materials, then perhaps you would have some time to get water to them and stop the fire, or at least give you time to get out of the house. The other thing that's really important these days are temperature management coatings, and there's a couple of ways this is important. For the roof of a house or the roof of a commercial building, you can have materials that reflect heat or absorb heat or shift the energy peak. There's a lot of different types of thermal management coatings out there, but these are going to become more and more and more important as we go forward, because of the heat that we're going to sustain. And also the building envelope around the building, the sides of the building, and all of the doors and windows and so forth. they're all going to have materials that help you manage heat. And in the utility market, it's very important to protect the switchgear and the substations, which I've pictured here. And why is this important? Well, inside these boxes are very sensitive electronics. And these electronics keep our grid, the electric grid, running. And if they fail, the grid fails. And if they fail, then we are very uncomfortable and we lose power to all of our areas, and obviously a big problem. So these substations and the utility companies are looking for ways to protect these boxes from heat overload. And this has been a global search, really, the global utility companies all over the world. The largest utility company in the world is based in Italy. It's called Enel, and they've had a call out for coatings that help control temperature inside these types of boxes. You can see over here, they've got an air-conditioned unit sitting on this trailer, and they're using an air conditioner to keep that one cool. But not everybody can put an air conditioner on all these boxes. So how can we control the temperature inside the box? We can use some thermal management coatings to help control the temperature. In addition, there's regulations that are starting to form that address our environment as well. And in California, as many things start in California, so goes the world, basically. I think also in Europe, there's some net zero energy regulations. But basically, this is called net zero energy ready homes. And basically, it means that the home itself produces as much energy as it's using. And so that gives a net zero effect to the grid and reduces greenhouse gases and so forth. So this would mean that the roof would have to be cooler, and we would have to be lower heat transfer from the roof inside to the home. The building envelope, the house, would have to be much tighter. It would have to have solar panels, so a lot more solar panel technology would be out there going up on roofs. As it is in Europe, there's a lot of solar technology already. And so these regulations are already in place, and they're starting to build new homes with net zero energy meeting these regulations. You're really trying to create a comfortable environment for the person inside the home. You're trying to produce a cost savings and take the demand off the grid, the electrical grid, and provide fresh air inside the house without polluting and having allergens inside the house. So there's a lot of reasons to have this, but mainly it's to take the stress off the electric grid. There's also other initiatives happening around lowering greenhouse gases. And this was the World Economic Forum has a platform project called Low Carbon Emitting Technologies Initiative, and has invited large chemical companies to join in to produce materials that are low carbon technologies. And as you can see here, many large chemical companies are participating in this effort. And this is just basically to say that you will see changes in your raw material supply based on the fact that these companies are looking for low carbon alternates to what they produce today. Because again, we're trying to reduce greenhouse gas. So this is a global effort, and this is why this is a global megatrend. All right, so now we're going to wrap it up here. I'm going to give you some final thoughts about what global megatrends do for you. So, we're in a very fast-moving environment. The megatrends can change very quickly as well. You think you're going in one direction, and suddenly a pandemic happens, and you're going in a completely different direction. And so you have to really respond. And so if you understand how these megatrends are going to affect you, it can help you think forward in a way to produce products that respond to those things. So the megatrend is influencing disruptive innovation. And as you can keep abreast of the trends, keep on top of it, finding out what's going on, you can, and developing products that respond to these changes, you can stay ahead of your competition if they're not paying attention. And so you can look for new opportunities to collaborate. For example, when we talked about electric vehicles, you can collaborate with battery manufacturers. You may have never even talked to a battery manufacturer before, but it's important to understand that these opportunities are out there and they weren't there before, because the megatrends drive you to new ways of thinking and new areas that are important. And so you can then develop innovations that are going to help your customers be happier, and that basically you can collaborate with others to solve problems faster. And so that's the message, is to really look forward, understand where the megatrends are taking us, and develop products that respond to the needs of those areas where the markets are going to be affected. This is very important for forward thinking in new technology. Last, I wanted to tell you a little bit about us and about myself. I work for ChemQuest. I'm the Vice President of Collaborative Innovation. And basically, we are a global strategy company and technology development firm. And we focus on specialty chemicals in the coatings, adhesives, sealants, and elastomers market. Basically, what we call the case market. And we've been around since 1976. We have a number of staff, 130. The majority of us are retired and have had careers and are now in our second career, if you will, with a lot of deep knowledge and experience in certain areas. And we try to bring that experience to our clients. And our client base is mostly in this area here. We have a lot of raw material suppliers who come to us for help with raw materials, understanding if they're the right raw material for use in the area. Manufacturers of formulated products like paints and coatings, adhesives, and so forth. And then we also have a number of people like investors and private equity firms and trade associations who are looking for information about the market. So when we look at our pillars of service, we're basically, again, looking at strategy and trying to help you transform your business by maybe moving in a different direction if you need to move that way. If you have manufacturing problems, we have people who have expertise in manufacturing, very amazing folks, actually. For technology development, I'm going to talk a little bit in the last slide about our ChemQuest Technology Institute. We also have a powder coatings research institute as well. And then finally, we have expertise in mergers and acquisitions. We do a lot of work for private equity and people who are either looking to sell their business or acquire a business. And I work a lot in this area these days on helping folks figure this information out. It's very detailed oriented work, but this is all of the different types of areas that we work in. And I wanted to mention the ChemQuest Technology Institute. Many consultants just basically give you information about things, but we not only do that, but we have a laboratory, as you can see here at the top. And basically, we are able to formulate, we're able to synthesize new chemicals, we're able to provide independent evaluations of things. For example, if somebody says they have a new technology and you're not really sure what it is, and you want to vet that technology, we're able to do that. We have all types of application equipment and production type application equipment in our laboratory. And we can provide a lot of different types of knowledge in education. We are consultants to a lot of different folks. We teach the Fraunhofer adhesive bonder courses. So there's a lot of things that we do in the market. So I just wanted to finish by saying thank you very much for your attention today. I certainly hope this has been informative for you, that you see that how megatrends can help you see into the future and drive your business forward. Thank you very much.
Thank you very much, Dr. Victoria. For this great presentation. It was really indeed very, very inspiring for all of us, I hope. I have here a couple of questions, but I hope we can, I'm afraid actually we cannot manage to answer them all. But let me start with the first question. Actually, this is to the organization committee and asking the availability of the recordings after the show. Yes, it will be available and shared by all participants after the Congress. And the first question to you, Victoria, this is from Engin Çorişli, the president of Science Committee. He's, first thanking to you for this great presentation and asking whether, saying that today we design the coatings and can foresee many properties without applying them on the substrate, except the appearance. So he's asking whether with all those new technologies, will it be possible to foresee what the wet and the dry film look like, and how will they appear without need to make a spray out?
Yeah, I think that the technology and software will have to be developed, and basically building a lot of databases. And there are people doing that now, and it's happening mostly at the university level. And this AI type technology is coming along, and there are many people who claim to have ability to formulate with polymers and see the polymers before they're actually formulated by, or giving you the formulated properties before they even build the molecule. And I think it's going to take a ton of work and database management and just a lot of iteration before we get there. And it's going to be a huge undertaking. And I've talked to several of these type of companies, and it does take a lot of groundwork before you ever get there. It will happen, but it won't happen tomorrow. It'll happen in the future.
Glad to hear that. Thank you. And second question is about the possibility of integration of the robotics used in R&D with the decision-making software. And the question is, can we close the loop for such as color matching tools in full automation with the technology available today?
With the technology available today, probably not, but I can foresee it within the next 2 to 3 years that the software to make decisions about color and being able to make adjustments would be possible. And I don't think that is as difficult a problem as the one we just talked about.
Just to extend this question, I also wanted to learn what type of test those lab robotics can do for the time being. Can you provide some further insight on that?
It depends on, they sometimes call it working for the robot, but what you do is you can work with somebody like a ChemSpeed and develop the robot to. They can do a scrub test, they can do a drawdown, they can do a viscosity measurement, they can do quite a bit. And so you work with the robot company to design the test that you need to be run, and then and they can do that. And once you get all of that in place, then what you're doing is you're formulating during the day, and then it's testing as the product comes off the line, and you get a lot of data very quickly. And so you can get maybe 100 formulas a day run if you're lucky. And but you have to be very careful, because sometimes you end up working for the robot, because if things happen on the line and you have to repair the robot or something's going wrong, you end up spending a lot of time there. But in theory and in reality, if everything's working just properly, you can do this, yes.
Thank you, thank you. And I'm afraid I can take only one last question. And for the questions that we won't be able to answer right now, we will convey them to you and appreciate
Okay.
your answers afterwards. So the last
I'll be happy to
question.
do that.
Thank you. So the last question is on the batteries. Do you think hydrogen and fuel cells would be a viable alternative to lithium-ion batteries? If so, what type of coatings would be needed for that?
Yeah, the hydrogen and fuel cells definitely would be quite a bit different from a battery technology. And obviously, in that case, you would need more chemically resistant technologies there. Your heat management would be still an issue, though, I believe, because you're going to be generating heat to run the car. So but you're going to be eliminating water, so maybe corrosion would be an issue as well. So there's always a trade-off whether you use one technology or another to make the automobile or the transportation move. There's going to be an effect, cause and effect, of what type of coating is going to be needed. It's not going to be, it will be totally different from what we have today, because these technologies are completely different ways to power vehicles. But I'm thinking more corrosion technology is going to be needed for hydrogen and fuel cell technologies.
Thank you so much. I'm afraid we need to stop here, so we need to conclude this session. Thanks again for this great presentation and very inspiring answers as well. And thank you all participants for your kind attention.